Alright guys, so here is our next example, and it's a word problem dealing with radical functions and transformations. So again, I left our little cheat sheet over here on the right so we can use that, okay? And let's go ahead and read the problem and then we'll go over it. So it says the function f of x equals the square root of 64 times x, right? This approximates an object's downward velocity, right? So it approximates an object's downward velocity and it's in feet per second. Okay, as the object hits the ground after bouncing x feet in height, okay? So essentially what they're saying is this. Let's just say you have an object, right? Okay, here is our object, here's our height, okay? Let's just say in this case you have a height of 60 feet, okay? And they want to know the downward velocity that's going to occur now. So what is going to be this downward velocity that occurs? And you can use this equation to figure that out, okay? Where your height would go in for the x, all right, and you'd be able to calculate, all right, that downward velocity in feet per second, all right? So that is essentially what they're saying here, all right? So let's continue to read on. It says this function is vertically compressed by a factor of 3/5 when used on Mars, okay? So this function is used on Earth, and they're saying if you want to use this on Mars, okay, in order for it to work properly, you have to compress it by a factor of 3/5, and this is going to be a vertical compression, okay? It then says determine how fast a rover will hit Mars' surface after bouncing, after a bounce of 60 feet. All right, so again, this matches up the diagram we just drew. Here's your height right here of 60 feet. Here's your rover. They want to know this downward velocity here. However, we can't use this equation because this is for Earth, right? We need to use the one for Mars, and in order to do that, we have to vertically compress this by a factor of 3/5, and then we can use that to determine the downward velocity that will be occurring on Mars for this particular problem, all right? So again, go back over here if you need to, all right? Maybe you don't need to. Maybe you have a strong base in linear transformations and you already know what to do. But when we're talking about a vertical compression, right, vertical pressure compression, we're talking about this A value here. So we're going to put 3/5 out in front, okay, of what we have here. So what we will have is the following. We'll have f of x equals 3/5, right? And then we'll have the square root of 64 times x, all right? So all you have to do at this point is go ahead and plug in your value for x. So again, our x value here is going to be 60, okay? So essentially what we're going to do here is do 64 times 60. So we can go ahead and write this out. We'll write it right here. So we'll have 3/5 equal, times the square root of 64 times, and we said 60. All right, so let's determine what this is going to be so we can use our calculator here. So we'll do the square root, square root of 64 times 60. We'll do times 3/5. All right, and you're going to get here 37. All right, so you get about 37.2. So what is that telling us? Well, that tells us that the downward velocity here is going to be 37.2, and we said it's going to be in feet per second. And this is going to be our answer here. Okay, so that is what's going to happen if your rover bounces 60 feet. Okay, on Mars you can expect a downward velocity of 37.2 feet per second. All right, and that is it.